Note out to where we left off yesterday. Yours make it up front here. All those receipts. Okay, so we ended up on page 32 here. And we're going to continue. And yeah, if you did the textbook work, there were some word problems in there too. So I encourage you to do that, to give that a try. So let's continue with this on page 33. So we're gonna spend a little bit of time on with this, and then move on to another, basically one of the last things we need to cover. So I'd like to get through that, and we can spend a little bit more time on those types, perhaps. Any one of those four. Okay. All right. Write an equation that satisfies the following conditions. So now we're going to kind of test our knowledge of what we've learned so far. Okay. You want it to be narrow, right? So A has to be greater than 1. We have the vertex, and you want 2 x-intercepts. The question does say that it wants it in vertex form, but it didn't have to. As soon as you're given the vertex, I would automatically go to the vertex form, right? The name says it all. It also is called the descriptive form, same thing. So let's construct it. We're going to go A is greater, right? Like anything greater. And you're like, what sign should be used, Mr. Erickson? I don't know yet. We'll figure it out. Okay. But this is what I do know. That this has to be X. If this is negative, then in the equation, it turns sign. Like when you bring that into the equation, the sign should change. And that is plus 4. Because the Y value outside doesn't change. And you want 2 x-intercepts. How would we make this happen? Well, go backwards. If k is positive, what would we want A to be? We would want it to be negative, right? Because we need them to have opposite signs. So that's when you go back here and insert the negative like that. Okay? So your vertex is there. You didn't have a choice to make 4. 4 had to be positive because of the vertex, right? So then I went back and changed that to a -2. Some examples, right? You could have any variation. We could have -27.85, right? X plus 2 squared plus 4, right? Like as long as A and K are different, we're in business. We have 2 x-intercepts. The vertex is still the same, right? So I could go ... here, right? You could go h of x, right? If you wanted to, -4.9 to x plus 2 squared plus 4, right? It all works out. It all works out. So what if you want to use y, f of x, h of x, g of x, you name it, it all works. Okay. What about the second here? You want it to be wide. points down is a giveaway, right? It has to be negative. A has to be negative. One x-intercept in vertex form. If it has one x-intercept, what do we know? If it's in vertex form, Jeremy. K is 0, right? Yeah, there you go. So some of the things are obvious. Some of the things are like, I don't know yet. I'm going to figure it out as I go. So let's write it. Y is, you want it to be pointing down. We want it wide. I just like to go 0.5, right? And then what about here? What does this matter? What the x value is of my vertex? No. So let's go, right? Squared, don't forget that. And then plus 0. I'm not going to worry about that, right? So points down is wide, 1 x-intercept, right? Boom. Right? If you want to go fancy, right? You can get as creative as you want. So if I ask you to write an equation, there have to be numbers in there, okay? That would make that happen. Let me zoom in a little bit. Okay. Next question, normal. A is equal to 1. Points down, A is negative. Right? Those are giveaways, right? Has a y-intercept of, how about if it just ended there? I hope you would have automatically gone to general form or standard form, because the vertex form doesn't have the y-intercept visible, right? In this case, it does tell you to use the general, right? So we're going to go y is equal to negative x squared, and then we can just go minus 5.78. Variations. Right? As long as this is 1 and it's negative, and you have your y-intercept at the end, and there are no brackets, we're in business, right? You don't have much, you don't have an alternative really with whatever's in front of x squared, right? You could, if you wanted to, do one of these, right? To really throw me off when I'm marking, right? But you still have x squared, right? You have a negative 1, so it's pointing down. It's normal because it's a 1, and my y-intercept is negative 5.7. So, you be as creative as you want, but just be careful. Don't be too creative and then make a mistake, right? Next, graph the following without. I'm hoping that none of this is really new. I'm just maybe reviewing some of the things. Graph the following without using a calculator. Not very popular, this one, but you should be able to do it. So this is in vertex form. Therefore, the vertex is dot dot like that, 1, negative 9. Remember what you need to graph something properly? The vertex and the intercepts. It's not a word problem, mind you. I should add that. That's not a word problem. This is just all 4 quadrants go here. So let's put this on our graph, 1, negative 9. It's right here. We know it's pointing up, right? So we know we're expecting this to happen. I'd like to have at least 3 points. So watch what I'm going to do. So this is my vertex, right? I'm going to find the y-intercept. And we know that x is equal to 0 at the y-intercept. I want to know, where does it cross here on the y-axis. So no problem. F of 0 is 2, 0 minus 1 squared minus 9. So I'm basically just substituting 0 in there. And that gives me 2 times, this is just negative 1 squared minus 9. You just have to know your bed mass here. What's negative 1 squared? It's so easy, but also missed easily. It's positive 1. If you have an even power, it's always going to be positive, right? So this is positive 1 times 2. It's just 2 minus 9. This is negative 7. What did you just find? You just found that, right, the y-intercept is 0, negative 7. That's what you just found. So we are over here. Okay. We're on page 33. So now, how would you graph this? Okay, you know that it's going to go here. If it's 1 over to the axis of symmetry, right, then it stands to reason that you'll have to travel the same distance to get to your point over here. So this point I just found using the axis of symmetry, and I'll show you here. 1, negative 9, and this is 0, negative 7 here. Do you remember the story, type 3? Right? If it takes you from here to there, if it takes you 1, what did we do to the 1 to get to the next? Just multiplied it by 2, right? And there you have 3 points. And that is good enough for me. Okay. That would be a parabola that has 3 points, and you're in business. But let's face it, if let's say it just says graph this, type this into your calculator, right? That equation. Let me just zoom out a bit. Always remember that. Type that into your calculator, find the y-intercept, find the x-intercepts, and the vertex is easy. You just have to read it and then graph it, right? Like you don't have to necessarily do this, but I want you to understand that we're doing the same thing. The ultimate goal is to graph this. One is more using technology, the other one is using algebra, right? All right, let's keep going. I will skip this for now. We're going to go to page 36. I'm not forgetting about the pages we're skipping. I'm going to use that to review later on. So page 36. I'm going to stop.